Hi guys, so this is our third extension video, which is kind of these optional ones that we're going through to get you guys just a little bit more information for some things we would have covered in the year if we had more time. So again, these are optional, just going through series and sequences. So today we're going to look at a pretty important one, and this one is a geometric sequence. So the sequence stuff is really going to be the same, just a different formula. It's going to look a little bit more like an exponential equation than it is going to be a linear equation. But when we get into the series for geometric, it's actually going to be, there's an extra part here that's going to be really important for you guys in future math classes. So we're going to start just like we did with arithmetic and looking at just the sequence. All right, so again, to figure out a geometric sequence, look and see what's happening between these two things. So for A, each term, I'm multiplying by 2. Okay, I'm not adding or subtracting, I'm multiplying by 2. Looking at B, I am dividing by a -3 to get to each term. All right, we know if we're dividing by -3, I also could say that I'm multiplying by a -1/3. So these are examples of geometric sequences. So in a geometric sequence, we do have a formula for this, just like we had for arithmetic. It's going to look a little bit more like an exponential equation because, again, common ratio, remember we looked at data and we determined what kind of data we had based off that table? Same concept here. So A is still your first term, and then R is the common ratio, what you're multiplying by. So I'm multiplying by 2. And then because I have A times that ratio, it's not going to be 2 to the n, it's 2 to the n minus 1. Because again, if I plug in 1, that would give me 0. Anything to the 0 power is 1, so I just get the first term. All right, looking at the next one. -3 is my first term, and then each time I'm multiplying by a -1/3. So what you'll notice here, if these signs are alternating, your ratio is going to be negative. So while we're not going to graph this, because again, we talked about that with exponential functions, look at you, if you had a graph that you'd go negative, positive, but you can actually write a geometric sequence with that negative ratio. All right, so now we're going to take another sequence. We're going to find the 8th term. So let's go ahead and write the sequence first. So that sequence would be the first term, the common ratio. Well, I'm dividing by 3, which means I'm multiplying by 1/3 to the n minus 1. If I want the 8th term, I'm just going to plug in 8 for n. And that's going to give me 2 over 243. All right, so again, sequences, it's going to follow the same concept. It's just a different formula. When you have a common ratio, those are your geometric sequences. So let's move on and look at partial sums. All right, again, same concept. If you know a finite number of terms in a sequence, then we can find that sum using an equation. So if this is your partial sum equation, the things still stand for the same thing. A is still the first term, n is still the number of terms that you're adding, R is just the common ratio now. So let's go ahead and find that information. Well, the problem here, again, we don't know what n is, okay? I know I'm adding until 768, but I don't know what term that is. So I need to start by solving for that. In order to solve for that, I need to use the sequence formula. Okay, so to determine a place in a sequence, I need to use the sequence formula. Once I know n, then I can plug it in and use the partial sum formula. So what I'm going to do from here, we know that 768 is going to equal A times my common ratio. Well, I'm multiplying by 2 here to the n minus 1. So then from here, I just need to solve for n. So I get 256 is equal to 2 to the n minus 1. Well, let's rewrite 256. That's the same thing as 2 to the 8th power. So if 8 is equal to n minus 1, then n is equal to 9. So that means I'm adding 9 terms in this sequence. Once I know what n is, I can set this equation back up using that partial sum formula. So I know that there are 9 terms, so I want to find the sum of the first 9 terms. So then I would do 3, 1 minus 2 to the 9th over 1 minus 2. Plug that in, And you should get 1533. So again, if you don't know what your n is, even if you're trying to eventually find a partial sum, you do need to use the sequence formula in order to determine what that n value is. All right, the next part is the pretty important part for future classes. So what we're going to look at now is, instead of finding a partial sum of a set number of terms, we're going to find what happens when that series just goes on for forever. All right, so let's look at the first one. 1 plus 2 plus 4 plus 8 plus 16. Okay, that is a geometric series. I'm multiplying by 2 each time. But do you think you can actually find the sum of that series that goes on for forever? Well, no, we can't. It's just going to get bigger and bigger and bigger and go towards infinity. So what we say in that case is that this series diverges. It doesn't actually come to an actual sum. Now, you may think that's true for every series. If you just keep adding numbers for forever, well, how are you ever going to find a total? That's not always the case, though. All right, so let's look at an example here. 1/2 plus 1/4 plus 1/8 plus 1/16. Again, this is geometric. Each time I'm multiplying by 1/2. Well, let's go ahead and look at this one visually. So I'm going to take a circle. I'm going to start with half that circle. Then I'm going to add a fourth. Then I'm going to add an eighth. Then I'm going to add a 16th, a 32nd, a 64th, a 1/128th. And you can see what's happening there. As I keep adding those little pieces of that puzzle, it's getting closer and closer and closer to one whole circle. So even though we're adding an infinite number of terms here, we're still able to find the sum. Now, again, as this goes towards infinity, it's going to get closer and closer and closer to that value. It's going to converge towards 1. So what that means for us, while the first one didn't work and the second one did, the difference between them was the ratio. All right, so that common ratio, if that common ratio has an absolute value that's less than 1, then you can find the sum of that infinite series. Now, we say absolute value less than 1 because if this was a negative 1/2, we could still find that total sum. But if it was a negative 2, the number negative 2 is less than 1, but the absolute value of negative 2 is not. So that is not something that we could find the sum for. So it's a very simple formula if it works, but again, you have to keep in mind it only works if the absolute value of r is less than 1. All right, so let's look at the next one. So the first thing we're going to do is we're going to find that common ratio. Well, I am multiplying by negative 3 each time. So my r is negative 3. That is not less than 1. The absolute value of that is not less than 1. So this series diverges. We cannot find the sum of that series. But let's look at the next one. Well, on this one, your r value is 1/3. So that is possible to find our sum. So I would just use this formula. So a is the first term. 1 minus 1/3. So that's going to be 27 divided by 2/3, which would be 27 times 3/2, which would be 81/2. All right, and then the last one. So this one's written a little bit different, but it's still asking the same thing. You're starting at the first term, you're going towards infinity. We can tell it's a geometric sequence, or we can tell it's a geometric sequence that we're finding the sum of, and we can tell what the common ratio is. Okay, my first term is 4. That common ratio is 3/5. So that ratio, it has an absolute value less than 1, so we can find the sum. So I would do a over 1 minus r. So I have 4 divided by 2/5, which means that I have 4 times 5/2, which is going to give me 20/2, which is 10. All right, so that is it for today. That's really all we're kind of going to get into with series and sequences on these little supplemental videos. The next couple, what we're going to do is kind of review some trig things that you did in geometry and kind of look ahead to some of the trig stuff that you're going to see in pre-cal.